All right, Unit 1 review continues. Number 27. Draw and label a picture of the following situation. Line C bisects segment AB at point W. So the first thing I'm going to draw is segment AB. With a point W. And excuse me, ouch. Now I need my line. It's called line C. Now, the key thing to this problem is there's some extra information trying to fool you. Line C is bisecting um, the segment. So the important piece is to understand that bisect means cut in two and cut into two equal parts. So that means AW is equal to WB. That's the most important thing. So now using that information, we can set up an equation with what is given in this scenario. We now know that this is a part equals part scenario. So AW again is equal to WB. So now substitute the expressions. 3x plus 8 equal to 5x minus 4. Solve for x. Subtract 3x from both sides leaves you with 8 equals 2x minus 4. Add 4 to both sides would leave you with 12 is equal to 2x. Divide both sides by 2, and that would give you 6 is equal to x. Again, read your directions. The directions did not say simply just find x. They want us to find AB. So now we're going to substitute. Oh, to find AB, we need to know the length of each part. So we're going to use AW because it has smaller numbers. That's why I'm picking it. But I could use WB. That doesn't matter. And I'm going to substitute x into AW. So it was 3x plus 8. So that's now 3 times 6 plus 8. 3 times 6 is 18. 18 plus 8 is 26. So again, what did I just find? I found the length of AW. So this length is 26. Again, that length is also the same as WB, so WB will be 26. So now I would need to take 26 plus 26, or 26 times 2, to figure out the total length from A to B. And that would give me 52. So the total length for A to B is 52. So make sure you read very carefully the directions that they ask for. I had to use AW in order to get to AB. But in order to use AW, I had to use X. So there was a lot of steps in this problem. But I can guarantee it's going to be an important problem that you will soon see. 28 says in the figure below, ray BR bisects angle ABC. So there's that word bisect again. So that means this little angle is the same as this little angle here. Then it tells us the measure of ABR, which is one of the small angles, is 4x plus 5. So let's label it. And it tells us the measure of angle ABC, which was the big angle. It's 46. So ABC is this angle here. Find the value of x. So I know that the two little angles make up the much larger angle ABC. So what I'm saying is angle ABR plus angle CBR will make up angle ABC. And then I know that they are equivalent. So I could just say 2 times ABR is equal to angle ABC. Because I'm only given ABR, but ABR is the same as CBR. So it's okay for me to do this. Knowing that, I'm going to solve it over here in this extra space. So that would be 2 times four x plus 5 is equal to 46, which is ABC. So now distribute the 2, and you would get 8x plus 10 equals 46. Now let's continue solving for x by first subtracting 10, and you would have 8x is equal to 36. Then divide by 8, and you would have a decimal, because 8 does not go into 36 whole. It goes into 32, but not 36. So 36 divided by 8, 4.5. X is equal to 4.5. 29. 29 says, in the figure below, what is the angle pair name for angle 3 and angle 5? So let's highlight those two. This is angle 3. And this is angle 5. So angle 3 and angle 5 share a wall, so they're adjacent. Together they form a straight line, so it's a linear pair. And then since it's a linear pair, it's supplementary. next question says, what is the angle pair name for 3 and 2? So here's angle 3 again. And then here's angle 2. So angle 3 and 2 only share a vertex, and together they form a perfect X. So these are vertical. Number 30, given points A at 610 and B at 1425. If B is the midpoint of AC, find the coordinates of C. So for this one, we know that A and C are your endpoints, and B is the midpoint. So we're going to do the EME method. Endpoint, midpoint, endpoint. A is the endpoint, C is an endpoint, and again, B is the midpoint. A is located at 610. B is located at 1425. So now we're going to establish the pattern between A and B that will continue from B to C, and that would help us find our coordinate. To go from 6 to 14, you have to add 8. To go from 10 to 25, you have to add 15. So let's continue this pattern again to find the coordinates of C. 14 plus 8 would give us 22. 25 plus 15 would give us 40. So point C is located at 2240. And number 2, find the ordered pair that is 3/4 of the distance from A to B. Since it's on a coordinate plane, those 3 steps from fractional distance are doubled to 6 steps, because what you do to x, you have to do to y. So the first step, let's find x by finding the total distance between my x's. So draw your distance skeleton, the absolute value sign, and the minus. Then insert your x values. A is at 6 and B is at 14. So the distance between those x's would be 8. Then we're going to find the fractional distance by taking the value 8 times the fraction in the problem. And the fraction is 3/4. Real quickly, without the calculator, that would be 24 divided by 4, which is 6. And then the third step, we're starting at A, and A's starting x value was 6. And if you were to visualize this on an actual grid, It's in the, it's actually, we only need the first quadrant because both x and y are positive. So in quadrant 1, you would have point A at 610, and B is at 1425. So that's a little higher up and to the right. So to move from A to B, you would go right and then up. So since I'm going right, I'm going to add my fractional distance. My fractional distance again is 6. And so 6 plus 6 would give me 12. So my new x value will be 12. Now we'll repeat those same 3 steps to find the new y value. So find the distance between our y's. The y's are located are 10 and 25. So the total distance is 15. Now find the fractional distance by multiplying 15 by 3/4. Without a calculator, that would be 45 divided by 4, which is not going to be an exact number, but I think it's 11.25. I'm pretty sure it's 11.25, but let me double check. Yes. All right. And now we got to write our starting x or y value. Our starting y value is 10. And since we have to go from 10 to 25, we're increasing. So we're going to add our fractional distance. So we're going to add 11.25 to give us 21.25 as our new y value. So the final thing I would do is write them as an ordered pair together. So that ordered pair would be 12 and 21.25. And this concludes your tutorial for this review. Good luck on your test next class.